Hey, George, you're a scientist.
I'm a chemist, yes.
Right. Sunscreen is a liquid, and liquids are chemistry. So I'm going to say that counts. How does sunscreen actually work? Because I don't think it's just like you cover yourself in a thick coat of paint and then the sun can't get through the paint. And if that is it, that seems like that lends way too much credence to the weirdos who insist sunscreen causes cancer. So I don't want that to be true. So, like, what is the sunscreen actually doing? And what the hell is an SPF?
Darn it, Lions. I am a environmental chemist, not a physical chemist, or a no, what is it called? It's not particle chemist. What? Materials, chemist? Not materials chemist.
Yeah. Materials. Because it's a material. Yeah. I'm sorry, I said it was a liquid, but it's in fact a material.
Yeah, exactly. It's not a liquid, it's a plasma. Oh God. Like that's what causes the burns, is you got to get to it before the sun does. But with my very limited knowledge and very limited expertise, I will attempt to opine to this. So the main question is what is light other than a miserable pile of secrets?
I mean, it depends, on your relationship with light, because sometimes it's like, hey, look at me, I'm a photon. And other times it's like, don't look at me, I'm a wave.
Yeah, it's like, what is it? Is it a photon or is it a wave? Hey, man, or is it, why not both? ¿Por qué no los dos?
Yeah. Is light literally the only thing we know of that does that?
I think so. It's the only thing that I know of where it's just kind of like, hey, I mean, like, honestly, I think that stuff like that is to me more evidence that we do just live in a simulation and it's glitchy, because they were like, hey, we're going to build a simulation so that way, because the thing is, like, it's like, well, how in the world would you build something that's made out of millions, billion, quintillions of molecules? It's like, you don't have to. You just have to build something that looks like a microphone, and then when somebody looks at it with an electron microscope, render what that would look like, right? But then somebody was like, hey, we're going to start taking a real look at waves, and it's like, oh, we never really built out that module. And somebody already observed it. Well, it's canon now. Hope they don't look too much further into it. But yeah, so basically light is a wave, right? That carries with it a fair amount of energy, right? And so we will now take a moment to diverge from our prepared remarks and for me to ask you a different question. One that I think we may have asked on this channel before, but one that I know we've discussed off the channel before. How do fireworks work?
How do fireworks work?
Yeah.
How do fireworks work? So you have, like a cardboard sleeve, I guess, that is filled with something that when it combusts, it is colorful to human eyes, right? And something that when it combusts causes propulsion. And then you aim it at the sky, hopefully.
Ideally.
Yeah, and light a long Looney Tunes cartoon fuse, it's on a stick. Yeah, so you have like the bullet bit, right? The explosive bit that propels it in the sky, and then separately you have the part that explodes and makes colors and you ooh and ah at. Yeah.
Yeah, you got like 98% of the way there. Very, very well done. The main thing is that like part of the incendiary device is that it's not necessarily stuff that when you burn it burns a certain color. More so what it is it's stuff that burns mixed with something that when you pour energy into it, it lights up a certain color. Right. So, for example, cobalt lights up blue. And so when you hit cobalt with blue wavelength energy, it absorbs that and then it shoots it back out. Right. As like, so you hit it with a wavelength of, I don't know, like 300 nanometers. I'm making that up. That's certainly not right, but I also don't even know if that's blue wavelength. But anyways, you hit it with something that's 300 nanometers. It absorbs that 300 nanometers and then it shoots back out 300 nanometers. Right. But one of the interesting things about that is that the reason why it kind of works that cleanly is because it is an atom unto itself, right? Like a lot of things aren't just atoms. We are living, breathing proof of that, right? We are organic, and as we've also spoken about on this channel, what are organic molecules?
I think the one characteristic is carbon.
Yep.
Yeah.
Carbon bonds, man.
Which, man, if we ever meet like silicon-based life, I guess we will have to decouple the concept of organic from the concept of things that are alive.
Yes, 100%. And even then, like the what is alive gets really fuzzy because like scientists have been like, okay, it needs to be, organic, and it has to like self-replicate and, two or three other qualities. And they're like, okay, so a virus, is it alive? And it's like, no, it's more like just a thing it's not alive. No, it's like, okay, but it replicates and it mutates and it does also other sort of stuff. It's like, yeah, but it's not cool, man.
Yeah, so, but we'd prefer not to think of it that way.
Yeah, considering the amount that we try to kill them, and the amount they try to kill us, like that's an ongoing war. But it's like, but bacteria, that's alive, and we'll kill that too. But one of the interesting things is that organic molecules tend to have a lot of carbon-carbon bonds, which, as we've kind of talked about, there are three types of bonds. Well, there's more than that. There's like 5, I think, but there's 3 big ones, right? Covalent, ionic, and hydrogen, right? And so organics have a ton of covalent bonds, right? And so within covalent bonds, there are a lot of different orbitals, energy levels, because they're sharing electrons, right? So, for example, you have a energy level that's like S. It's called the S orbital, right? And then you also have the P orbital. But then when you get an S orbital and a P orbital together, they make like an sp2 orbital or like an sp3 or an sp something else. My organic chemistry is a little fuzzy, but like depending on the number of bonds, what's bonded to the thing that's bonded, the orientation of all that sort of stuff, it's got all of these different wild like structural energies, right? So as opposed to just an atom, which is nice and clean, organic stuff is like way messy and sloppy with the way its energy is, right? So what that means is that one part of the atom, right, or not the atom, the molecule, can like absorb a certain wavelength of light, right? And then what it does is it gets its funky flow on, and it just kind of passes that energy kind of like around the molecule, and then it can release it, but instead of releasing the exact same wavelength of light that it initially got, it can release like different wavelengths of light because it's kind of it kind of has parceled out that energy across the molecule. That kind of makes sense?
Yeah.
Yeah. So it's kind of like instead of, if I'm dealing with a company with one person, it's like I give you I give you $20, I expect $20 back, right? But if I give you $20 and then you spread the money out across your entire family, and I'm like, okay, give me the money back. It's like, okay, well, they're going to give you $2 and they're going to give you 15 and they're going to give you 3. And it's like, okay, I still got all of my money back, but I got it in weird parcels, right?
A bunch of it's quarters now, and I hate that.
Exactly. Or God forbid, pennies, man. Why are we still making those again?
They're not money. Every time my kids are like, oh, I found a penny, I'm like, no.
No, value your time more than that. And then the worst thing too is that when you pick them up, it can make the oils in your hand smell bad. Now the penny doesn't smell bad, but the oils in your hand smell bad. And we did a whole episode on that if you want to check it out.
We did. Copper.
This entire episode is just going to be shilling for
just
other
all
episodes.
Callbacks.
I imagine that as we continue this, it will build into that because it'll be like, okay, well, this uses the same principle as this other thing, because that's the nice thing about science is it builds on itself. So what the chemicals do is that are in sunscreen is they are made specifically to absorb UV radiation, right? So they have some bonds somewhere on the thing that says that UV radiation, don't worry, fam, I've got that, and it will absorb that UV radiation. But now it's excited and it's got to do something with that, right? Now, if it was like an element, it would just emit that radiation and just pass it right along into you, right? But what the molecule does that's kind of cool is it parses it out. So it actually then, when it releases it as heat light, not ultraviolet light, which is a substantially lower energy and, more importantly, non-ionizing radiation, which means it doesn't have the energy to do fun stuff with your genetics like UV radiation does. Yeah, because chemistry doesn't care about you, like once it gets enough energy to do something fun, the molecule will do the fun thing because it doesn't really care that it's part of like a greater whole. So, yes. And so basically as it absorbs the light, the UV radiation, it then, disperses it as heat energy, which prevents it from damaging your skin or your DNA.
So you get like this is the organics that are in your body, right? Because you have some natural resistance. Do you get like, is sunscreen just like a mass of like organic compounds that you're slathering on so that they perform the way your flesh would, but more?
So I would argue that first of all, it's not like there's as with many different products, there's the active ingredient and then like a whole bunch of non-active ingredients, right? So it's not just the chemical. There's like a whole bunch of other stuff in there that like helps it, go into your skin and helps it not do chemistry with itself and form a polymer, which would actually make it into a plastic, which we did an episode on. I say all that to say that I would make the argument that it actually does a significantly better job than your skin. More so because your skin's answer to the problem is to, clog the rivers with their dead, because your skin is like live cells that have then like died and formed a protective layer. And they're just desperately hoping that there is enough layers of dead to prevent it from getting to like live, still replicating tissue. This is something that was like made specifically to dam the river, not just, being like, well, if I throw enough dead bodies in the river, won't that solve the problem? It's like, it will. That's a lot of dead bodies, which is also probably why when you're slathering this stuff on, it doesn't have to be like 3 millimeters thick like your dead skin.
So that's exactly what I just wanted to ask you is, so you put on sunscreen and you have like, it doesn't magically protect you infinitely, right? So if you are light skinned enough or you're exposed to the sun for long enough, you will still have problems, but it also doesn't just last forever. So like, what is like, how much more protection, right? Is that the SPF, the sun protection factor? Like how does it change up an individual person's protection? And why doesn't it just last like until I wash it off? Where does it go?
So a couple things. One, is that, so the SPF factor, there's like math behind that I completely forget what it is, but SPF 15 blocks 93% of UVB radiation, 30 blocks 97%, and I think 50 blocks 98%, 100 blocks 99%. So like as you're going up, you get diminishing returns on like the percentage increase, right? Also, this is the point where I feel the need to say, like, I am not an expert. Please don't listen to me on exactly how much, where's sunscreen? Sun radiation can be bad for you, but also listen to true experts, not, rando George. So then the question is, why doesn't it last forever? Well, ostensibly, the molecule can break down over time, right? Organics tend to do that, but they don't tend to do it over the time periods that you would be thinking about it, right? Because it's like, oh, reapply sunscreen every X amount of time, right? I believe that it is the main, well, two things. One is that it blocks 97%, let's say, of the sun's rays coming in. That's not 100. So if you stay out in the sun, long enough, that 3% becomes a problem, right? So that's why it's, it's like, oh yeah, reapply and do all this sort of stuff because, like, and also still don't spend forever out in the sun, but also too, is that, I would believe that it will just kind of last forever. The reason why it doesn't is because your body's really good at getting stuff off of it, so like not only do you, wash yourself, but like you sweat and you have oils and all of that sort of stuff just eventually comes off of your skin. And unlike with natural oils, which replenish themselves, the sunscreen does not, so
that just gave me a terrifying vision of like CRISPR modifying someone so that their sweat is sunscreen, like they just produce sunscreen.
I'll tell you what, man, as somebody who is as light-skinned as I am, I would pay money for that, like the amount, because as I said to somebody at one point, they were like, why don't you like going to the beach? And I was like, because it's a stressful event for me, because if I don't properly apply sunscreen like every hour on the hour, if I forget, or what happened to me recently where I thought I had applied it, but like I had missed a couple of spots, physics doesn't care that I tried my best, like it's like, oh, you missed a spot. And I'm like, yeah, but dude, physics, come on, man. Like I was responsible adult. I added sunscreen. I did all other sort of stuff. Nah, man. I'm still gonna throw all that ionizing radiation at you. And also Side note, it's my understanding that the thing that makes your skin red isn't the sun itself. It's a byproduct of your cells dying, and more specifically, other cells telling the corrupted cells to kill themselves, which I think is wild.
And that is like a level of specificity that is scientifically important, so thank you. But also like colloquially meaningless, right? It's like, well, it's not really the sun that's making your skin turn red. It's the thing the sun caused to happen. And it's like, yes, those are technically different.
Yes.
But you mentioned, you are quite a bit paler than I am, right?
So pale.
So I remember hearing as a kid, the SPF sun protection factor is like literally multiplying, right? So if you are, I don't know, a certain shade of pale, then SPF 30 is literally doing less for you than for someone who is darker skinned than you are, because it is not like a concrete number. This blocks this much UV radiation. It's that it gives you like buffs to your ability. Is that actually how that's measured? Because that seems insane to me, but that's the only explanation I've ever heard.
Well, and no, I don't think so. And the reason why is because I don't know how that would work. But I think but again, to your point, you may be colloquially correct, right? In the sense that your body, so like let's say that your skin naturally blocks 90% of UV rays, and mine naturally blocks like 10%, right? Like it's bad, right? Because I don't know, like how long on a sunny day can you be out without sunscreen on?
At sea level?
Let's say in Colorado, let's say that you were there between the hours of like starting at 10 o'clock on like a summer day. How long could you be out before you'd be like, I need to?
Yeah, at altitude, probably an hour.
Yeah, like according to my app, because I actually have a UV index app because that's how bad it is. While I was visiting you in Colorado, there were a couple times when I checked it and it said, you have 20 minutes that you can be out in the sun before it's going to cause a problem for you. And I was like, that's like vampire levels of, anyways. So I say all of that to say that, if you block 90% of the sun's rays, right? And the SPF blocks 90% of the sun's rays, then that means 2% of the sun's rays are getting through, right? If I have 10% and the thing's blocking 90%, then substantially more of the sun's rays are still getting through, right? In that case, like 10% is still getting through. So kind of in the sense that that's just kind of the way the math works, but it's not actually like the chemical isn't handshaking with your melatonin and like somehow forming like this like super chemical that like multiplies. It's not Super Saiyan 3, but mathematically, right, is that if you're naturally darker skinned, then you will have naturally more protection, and so the SPF will do more lifting on the difference.
I want to know where the sunscreen brand is that like that's their marketing is like the little anthropomorphic sunscreen and the little anthropomorphic melatonin like doing like a one pump handshake and they're like, yeah, we're going to protect this guy from cancer.
See, well, I thought you were going to go with this. It's like the, representation of sunscreen and the molecule representation of melatonin molecule. And they just go, fusion, ha. And it just like shows, somebody that looks like, those beach people where it's like they're super tan, and like just ripped as hell. Yeah.
Well, and you know what I just realized is it would be the fusion dance and not the Patara earrings because the sunscreen eventually wears off.
It does. And always at the worst time, right? Because they'll be like, all right, I just went swimming.
Insanely, this does actually remind me of another thing I wanted to ask you about.